Good morning, everybody, and a warm welcome to this Baltic breakfast. My name is Gun Rudqvist, and I work at the Baltic Sea Centre at Stockholm University. And we are today organising this Baltic breakfast in English. We normally do them in Swedish, but this is such a hot topic, and we would like to reach out and have an increased dialogue with all of you guys around the Baltic Sea. So we're going to talk about the Baltic Sea Action Plan, an action plan that is well known by most of you, I suppose, and we will dive into science behind the existing plan and science leading and contributing to the new plan. Just before we do that, a few words about the Baltic Sea Centre. We are, as I said, a part of Stockholm University and of course a research centre. There is a fabulous research station called Askö just south of Stockholm in the archipelago. But we also work a lot with supporting decision makers and other actors in society by, for instance, the work that's done at Baltic Nest Institute, a collaboration between a couple of universities and led by Bo Gustafsson, who will join us today and talk about eutrophication. And we have also a specific task to talk and do communication work in a broad sense, both reaching the general public but especially increasing the dialogue with actors within society. We can do this in a different manners, of course, and for instance, these breakfasts are an example of this. But we also try to synthesize knowledge by producing policy briefs you can all reach them through our webs. And we try to facilitate dialogue by creating platforms and also, of course, putting Baltic Sea issues on the political agenda. So today, as I said, Baltic Sea Action Plan is what we're going to talk about. And we would love to have all your questions during this webinar. So you can post this question in three manners. You can go to Slido with the code 85397, or you can use Twitter at Ostersjöcentrum and hashtag Baltic Breakfast. Or you can also send us an email, ostersjöcentrum.su.se. And we will try to handle as many questions as possible, of course, but if not, we can't manage to in time answer all your questions. We will gather them and try to formulate answers, and we will put them on our web. So, and we will also, if possible, try to reach you directly. So please, it's very nice if you put your names and maybe where you come from in your email or in your different communication with us. Well, let's talk about the Baltic Sea Action Plan. Sorry, let's go back one. No, I'm sorry, we thought we had our names of our wonderful speakers here, but I will present them for you instead. The Baltic Sea Action Plan, well, I think you're all familiar with this. It was decided on in 2007, and it's up for revision. Hopefully, the ministerial states around the Baltic Sea will decide on a new plan in 2021, or the fall of 2021. And of course, a lot of things has happened since the first plan. I think we all know that the targets will not be reached. But we will not talk so much about details of implementation, etc. today, because there's been a number of seminars dealing with this. We will instead talk a bit about research, what has happened in research since the first plan, and look at how did it contribute then, and how has it contributed to the next plan. And to help us with this, we have two excellent speakers with us. First is Bo Gustafsson, who is a researcher at Baltic Sea Centre here at Stockholm University and also at Helsinki University, and also the director of Baltic Nest Institute. And the Nest Institute have done a lot of the marine modelling as a support decision system to, for instance, HELCOM. And Bo will briefly recap how maximum allowable inputs and country-wise reduction targets were obtained when the first plan came about, and then briefly present proposed updates to the nutrient reduction scheme for the upcoming Baltic Sea Action Plan. And after that, we will move on to talk about chemicals. And to help us with that, we have Emma Undeman, a researcher in environmental sciences with focus on chemicals. And she has, together with research colleagues, supplied HELCOM with very important background reports looking into hazardous substances in the Baltic Sea. And you can, of course, get your hands on these reports through our web. And she will present the challenges of developing new measures in the plan and how does this come about and what are the obstacles here. So we will move on directly into the program. So Bo, the floor is yours. Bo Gustafsson.
Thank you. So, as Gun said, I will talk about the eutrophication segment of the Baltic Sea Action Plan. And Gun already introduced that the Baltic Sea Action Plan was launched in 2007, and with agreeing on actions to achieve a Baltic Sea good environmental status by 2021. And as we are approaching 2021, it's of course natural to update this. I will talk about the eutrophication part, as Gun said, and what was really pioneering in the Baltic Sea Action Plan in 2007 was to really quantify on a scientific basis how much should nutrients be reduced, and also that the countries took responsibility for sharing the reduction necessary. And this had subsequently happened in, for instance, Chesapeake Bay with an agreement 2010 and Lake Erie in 2013. And there is also other implementation of what's called critical load or sustainable load in other regions. But this was really pioneering, and especially also on the international scale, having several countries agreeing on this. Today, as Gun said already, I will briefly recap how this nutrient reduction scheme works or was built up. And then I will briefly show what updates are planned now for the BSAP update. So the approach to management or the way these targets are obtained is that the HELCOM have agreed on environmental objectives. What is the state of a healthy Baltic Sea that will be achieved? And these are mentioned in words, like these sentences here: clear water, natural concentrations, etc. But to use that to really scientifically quantify how much we need to reduce to obtain this environment, we need to put numbers on this. And that was the first scientific part of the nutrient reduction scheme, is to convert these objectives into numbers. And for that, one chose a number of indicators, and for the indicators, one then find values based on modeling and observation and long time series. Once we have those values, we can use numerical models to back calculate what loads, how large loads can the Baltic Sea cope with, and still ensure that these targets eventually will be reached. And then the last part was a kind of mixture between science and policy. How should this be shared between the country? And the scientific part of that is to quantify nutrient input shares for the different countries, and also look at the uncertainty in different parts. So, for the BSAP update, the first 3 elements of this is decided to remain. Of course, still it will be, this is a process, and the ministerial meeting will set a decision on the Baltic Sea Action Plan a year from now. So of course it's still a possibility that they will throw out everything, but there's no way at this time now to do this full recalculation from the objectives to the maximum allowable inputs, because it's much too short time. So that will not be done, and it was decided some time ago that it shouldn't be done. However, we are going to change the allocation from what we had before was a reduction target into what we now want to have an input ceiling instead for the countries. And what do we mean with this? So in the old agreement, or in the present agreement, we should say, in the documents there is a reduction for each country to each basin. That should be achieved. The problem with having just a reduction is that you need to reduce compared to something. And what happened now in these 7 years is that the what we call reference inputs around year 2000 that we compare with, have actually changed because of new data and new models. And that leaves us some problems. But if we have nutrient input ceilings, if we now decide exactly how many tons should each of the country be allowed to emit, we are not dependent on carrying on looking at old data. So we can strictly look forward. And in addition, we have these nutrient input ceilings, or will then for a basin, like in this example, add up to the maximum allowable input if you take account all the sources. This is almost a recap of what I said before, but the good things with the nutrient input ceilings is that they directly gives information on the permitted inputs. And one problem that has been also with the reduction targets is basins where we don't need additional reductions. Then it's just zero in all the tables, and you don't see if a country, you need to have a clear direction if some country is emitting more nutrients, what is the limit? We have actually used a kind of nutrient input ceiling for evaluation for quite some time, but they are then not solidly funded in the old documents. And then I said this with data updates. So what we do now, or have done, but it's under negotiation now, is that we recalculated this allocation, but using the same principles as was used in 2013, that the reduction is shared in proportion to nutrient inputs in a period around 2000, and we should take into account some expected reductions from other agreements, like the Gothenburg Protocol on air emissions, and also expected reductions from shipping due to these NECA agreements. And also the upstream countries like Belarus and Ukraine and so on, we should put a burden on those, although they are not contracting partners in HELCOM, we should give an indication what we expect from these countries in terms of reduction. What this update further considers is that it's been a wish, or that since HELCOM is a convention, it should also cooperate with river basin commissions and river basin convention, or under that convention. And therefore, there's been a wish to highlight these what we call transboundary rivers that have contributions from upstream countries. And of course, update the data. And this with the major rivers, it's very important also to follow up, because they have a very large proportion. If you pick out these 10 rivers that we picked out, or 8 rivers, they contribute with about 50% of the loads, of the waterborne loads to the Baltic Sea. And the results show, it's very difficult to show the results here because it's just big tables with numbers, but in general, there's not very big differences. For instance, for Sweden, the differences are a few percent. However, the new data on atmospheric deposition provided much higher atmospheric deposition into around 2000 due to new data and new emissions. And that gives the ceilings to higher ceilings for countries with a large proportion of atmospheric deposition on the expense of countries with high proportion of waterborne nitrogen inputs, because the waterborne load haven't changed so much. And there is also some other new data that caused some changes. There is also, from that it could be interesting to note, is that there will be less expected reduction from the international shipping, because now we have better models on that, and it's calculated somewhat different. So what is happening now? The methodology have been extensively discussed with this. We worked on developing the numbers for approximately 1.5 years now. And in April, we actually presented a complete proposal with numbers at the workshop. And now that is delivered to heads of delegations and the representatives from the contracting parties that have to decide how this should be adopted in the Baltic Sea Action Plan and what kind of text and agreements it should be around these numbers. So, and there's been this workshop called NIC Workshop 1. You can find documents and presentations on the HELCOM meeting portal from that, if you'd like to read more. And the most recent, if you want to dig into the numbers and how things are calculated, the most recent version is available from the PLC 7-11 meeting, the 11th meeting of the PLC group that was in June, and that's available also on the HELCOM meeting portal. So that was mine.
Thank you, Bosse. Great. So the picture you're giving us is really a lot of change, yes, but still a few core elements are still remaining, right? I was thinking, you said in 2013 you made a revised calculation of the maximum allowable inputs as well. Should not that have been recalculated as well, and not just the country allocations?
Yes, I think from a scientific standpoint, it would have been very interesting to redo the whole analysis, also calculating these targets again, revisit that. However, I don't think still it would give a dramatic shift. I mean, the important thing with the maximum allowable inputs, that I see it, is they are of course very uncertain, but they give really a scientifically founded level on where we need to go, compared to how it was before, where we just had like 50% compared to an arbitrary year.
Okay. So that's a good thing. I mean, scientific solid base, that's nice to hear.
Yeah.
And as you said in your starting of your presentation, you pointed to the fact where science comes in and where it's actually a policy decision, assumptions, assertions, appreciations. Would that mean that if you look at what the slide you had saying that the original goals, talking about how clear should the water be, what kind of, how do we want the water to be really? That's a policy decision to a large extent, of course.
Yeah, totally.
Yes,
say.
of course. Would you actually say that these goals should also be reconsidered?
I think one needs to close the loop somehow. I mean, eventually we will come to a stage, probably we will come to a stage, I would say, not definitely, where the last tons are so intrusive on our lifestyle or on the budgets that we don't want to do them. And at that stage, I think my dream would be to be able to have better tools so we can illustrate trade-offs in a way where we can show the politicians that, well, if you stop now, you will get something that you could say to the quantitative information that you could say to your what's called your public that votes for you. That way, well, it will be maybe not perfect, but it will be pretty good, and we will get this amount of code, and we will get
so
these
it's as
values.
always, you have to weigh things, and it's a cost to that.
I mean, now it's very difficult to compromise because we talk in these targets about 0.5 in a concentration.
Yeah, okay. So that doesn't really mean anything for
No.
us who are sort of as a layman saying
No,
it.
no.
Thank you very much. We will get back to these issues in the debate, but let's move on. All right, so let's move on to chemicals. Emma Undeman, please join us here, and we will get a bit of more information about the hazardous substances and all the work you've been doing with these background reports.
Yes.
Please, Emma.
Thank you, Gun. So, since the HELCOM, the Helsinki Convention was signed in 1974, the conditions in the Baltic Sea has changed considerably. As you know, the emissions of hazardous substances were at that time associated mainly with point sources, such as industries. And today we live in a society where we have chemicals everywhere, and many hazardous substances actually are diffusely emitted in the Baltic Sea region from thousands of small sources, which are much more difficult to manage. The regulation of chemicals has developed considerably over the last decades, and we are much more aware of risks associated with chemicals today. And the geopolitical situation in the Baltic Sea region has also changed a lot. When the convention was signed, that was before the breakup of the Soviet Union, before the reunion of Germany, and since 2005, 8 of the 9 contracting parties that are nations are also EU member states. So this means that the role of HELCOM in this region has changed over time, and also the type of actions that are needed to manage hazardous substances has changed. And if you look at the Baltic Sea Action Plan, as it was written in 2007, you can see that there are different types of measures, and there are different ways to categorize these measures. Many measures are investigative measures, where you are basically agreeing to look for more information before you make a decision on how to move on. Many agreements in the plan is to develop monitoring and assessment strategies. For certain chemicals, there are actions that means that they are the nations will work to ban these or restrict the emissions somehow. Other actions are to implement already agreed international conventions, for example, the Minamata Convention on Mercury or the Stockholm Convention on Persistent Organic Pollutants. The plan also includes to develop guidance for nations to use end-of-pipe measures. For example, this mainly considers treatment of different waste streams. But maybe the most fundamental categorization in the plan is between those actions that address already identified hazardous substances and those actions that aim to address emerging or even unknown chemical threats. And this emerging and unknown threats is something that HELCOM is not really that good at working. This category of actions are not so well developed, because as we all know, hazardous substances is a moving target. If you're managing eutrophication, you know that you have to reduce emissions of nutrients, but the problem with the toxic effects in the Baltic Sea is related to chemicals, and which chemicals that are important change over time as we manage some, but new contaminants appear in the environment. The HELCOM Baltic Sea Action Plan certainly includes actions that are supposed to address this, but these emerging and unknown chemicals. But these actions are actually not really concretized and not, in many cases, not implemented. But the work that we at Stockholm University have done to support this update of the Baltic Sea Action Plan, this is about coming up with actions for those chemicals that are already identified as hazardous and that are still considered to cause problems in the Baltic Sea. So currently, HELCOM work is much focused on these legacy pollutants that have been around for a long time and that are in many cases banned since long. Then they are also often global pollutants that are emitted in many regions of the world and may reach the Baltic Sea via long-range air transport. HELCOM focus much on monitoring of these substances. They keep track of the environmental concentrations to see how these develop over time. And the monitoring is focused on a limited number of indicator substances. These are used to evaluate the state of the Baltic Sea, the chemical status of the Baltic Sea. So the so-called core indicators are used in the reoccurring holistic assessments. And the last one was done in 2018. And you can see in this graph the ratios between the observed concentration in the sea and a threshold that defines good environmental status. And to the left you see the lower ratios where the concentration is below the threshold. And these red bars indicate a range of ratios that are exceeding the threshold. So actually just a few, according to this assessment, only a few substances actually deteriorate the status in the Baltic Sea, and that is PBDEs, mercury, cesium-137, and TBT and IMPO6. But in addition to these core indicators, HELCOM is constantly working with developing new indicators. And that can be a very long process. But HELCOM is working with test indicators and so-called pre-core indicators that may be used in the next holistic assessment. For example, TBT is such a more of a test indicator that was actually included in this assessment. So for the Baltic Sea Action Plan, the update of this plan, according to this strategy, HELCOM has now identified problematic substances and need to develop additional actions to reduce the levels in the sea to reach the good environmental status. So what we have done in this work is to contribute with scientific reviews that describe what we currently know about sources and transport routes and temporal trends for these substances. So because it's important to identify the major sources and transport pathways that are relevant to the Baltic Sea, because that is not necessarily the same as, for example, in inland water or a river and a lake. So it's important to be aware of sources that are important for the entire Baltic Sea and sources that may be only important in local areas. And we also reviewed temporal trends published for this region. These can tell you if it's going in the right direction and when levels might actually drop below the thresholds with the current rate of decline or if it's declining. So we did this for 4 different substances or substance groups. The pharmaceutical Diclofenac, the very well-known PFOS, one of the most famous PFAS, the highly fluorinated substances, dioxins and PCBs, and the polybrominated diphenyl ethers, PBDEs, the flame retardants, and which are also banned. And several researchers who are contributing to this work, either as authors or reviewers of these reports, which are published as Baltic Sea Environmental Proceedings in HELCOM. So I'm just going to briefly go through a few highlights from these reports, and I hope that will make rise some interest to read the actual reports later. So for PFOS, the current knowledge tells us that the input via rivers is about 3 times higher than the atmospheric deposition directly to the sea surface. But the PFOS in the rivers originates from atmospheric deposition onto the land, in the catchment, and which is then transported via shallow groundwater into the rivers. PFOS also enters rivers directly via wastewater treatment plants. So urban emissions of PFOS enters the wastewater stream. And there's also contaminated sites around the Baltic Sea. PFOS stored in these contaminated sites can reach the water system via groundwater or drainage ditches, for example. But the relative importance of these different sources is not quantified and is not known. So it's very hard to judge which, if, for example, better treatment in a wastewater treatment plant or remediation of contaminated sites will have any importance for the Baltic Sea as such. There are no known direct sources of PFOS into the air in the Baltic Sea region. PFOS is banned and the production was phased out a long time ago. But new PFOS is actually formed in the air from precursor substances, substances that break down to PFOS. So concentrations in air of PFOS will decline when we stop use precursors. And we still have a lot of PFOS stored in soil and the sea. So to look a little bit at Diclofenac, the pharmaceutical, here it's easier. The major input is via municipal wastewater treatment plants. This substance is not really persistent or bioaccumulative, but the concentrations are sustained in the environment by continuous emissions. And we can see that in the Baltic Sea region, prescribed Diclofenac is actually declining, mainly because the cardiovascular risks associated with this pharmaceutical. But sales of Diclofenac in creams that you apply on your skin may actually be increasing. These creams don't require a prescription and are not associated with these health risks. So if we look at data from Sweden, for example, we can see the total mass of Diclofenac that is sold has decreased over time. But if you just lift out the non-prescribed part of this mass, that has actually been increasing between 2010 and 2017. And the largest part of this non-prescribed Diclofenac is also creams. So when you take a Diclofenac pill, the largest part of the substance is metabolized in your body. But if you apply Diclofenac on your skin, a rather small fraction is actually absorbed. Most of it is then washed off from your skin or clothes that have absorbed the Diclofenac, and it can, via this pathway, reach the wastewater. But this is a large knowledge gap. How much of these creams are actually sold in the region and how much actually enters the sewers? So just to mention a few things about PBDs and dioxins. For PBDEs, which are also banned, we still have primary emissions from products that we have in our homes and also from waste in landfills and etc. But it's really difficult, still difficult to weight the contribution from these two sources. When it comes to dioxins, we know that for the entire Baltic Sea, the atmospheric deposition is the primary source, but where the dioxins in there comes from is actually, there's a knowledge gap here. We can't explain the levels in the atmosphere, but it's suspected that it's small-scale uncontrolled combustion that is this unquantified source that could explain the levels. So to sum up here, or to finalize this talk, we can conclude that there's really a lot of research needed to support HELCOM in updating the Baltic Sea Action Plan. One key thing that is often lacking when HELCOM is proposing actions is what is the effect expected from this measure. It's really difficult, but it's also, of course, needed to know if we implement this action, on what scale will it be effective, and how much will concentrations be reduced in the environment? What do we expect? So you need to describe the scale of a problem. Are we looking at the entire Baltic Sea or only perhaps coastal zones? And for each scale, you have to define which sources are relevant. In a coastal zone, you may have a contaminated sediment that is actually causing the elevated levels, but in the open sea, you may be more interested in the atmospheric deposition. So when you have the major source is actually global emissions, this is a very difficult situation for HELCOM because you need global cooperation. But regional emissions are certainly more easy for HELCOM to cooperate around. And finally, as I mentioned, that HELCOM also needs help to identify the problem. Which chemicals are a problem in the Baltic Sea, and what are the effects of these chemicals? And here, researchers are working on novel analytical methods, new ways to monitor, and how to exploit emission data to predict which chemicals may reach the Baltic Sea. But here, researchers need to do this tailored for the Baltic Sea, because that information is needed by HELCOM to develop their actions. And more. So thank you for that.
Thank you, Emma. Wonderful. No, stay with us here, and we'll soon ask Bosse to join us again. But just a short follow-up question first. As you said early on, I mean, the picture you're drawing and giving us is a few identified really difficult substances, of course, and a lot of focus on these. How much is hidden sort of under the water? I mean, how much do we don't know enough about? Are we only sort of working with the tip of the iceberg?
Yeah, that's a good description of the situation. But of course, these legacy pollutants are in many cases extremely toxic and have proven to have really severe effects in the Baltic Sea. But because of how HELCOM, the lack of really updating the list of prioritized substances maybe hinders to move beyond these well-known substances and see if there are other groups of chemicals that also need to be managed and that are relevant in the Baltic Sea.
Mm-hmm. So would you say that the discussions are like the discussions you can see here and within the European Union about working with one single substance instead of grouping them, etc.? Is that the same kind of problem?
That is the key, one of the key questions that has been discussed for a long time, both in HELCOM and at EU level. So how can we go beyond this single chemical approach in regulation and in assessments? And there are certainly discussions at the EU level how to take a broader scope, maybe using effect-based monitoring and this non-target screening monitoring methods. And that is also discussed in HELCOM. So there's a communication between,
of course, as
HELCOM.
you said,
So
8 out of 9 countries.
It's sometimes hard to know who's leading, but these discussions are ongoing. Then, of course, HELCOM countries know that they have to fulfill EU directives. So they are, of course, interested. HELCOM is interested to know where EU is going.
Of course, yes.
In these questions.
Thank you, Emma. Bo, please join us, and we will dive into more questions. Maybe just sort of where you left off almost. I mean, you've all pointed to the fact that HELCOM is a convention, it's a voluntary agreement. I mean, it's a joint effort between all the member states around the Baltic Sea, and the role of EU legislation. Has this attitude changed? You've been around with Baltic Sea issues for a long time and also worked with a plan. Would you say that the HELCOM as such has the same strive now to sort of do these things jointly? Can we get more countries sort of to actually implement? I mean, there is a lack of implementation.
Yeah, I think HELCOM is still has an important role as being focused on the Baltic Sea, which is a very special regional sea compared to the others in the EU. And then, of course, whether HELCOM is ahead of EU legislation or just on the line of EU legislation, that is basically reflecting then the political situation in the member countries.
Okay.
I would say.
So it would be love actually to have science to more step up and also be a part of this dialogue, right? Science should be there more.
Yeah, I think politicians and other decision makers want to communicate with the researchers, but there's often not enough time to do it.
Yeah, we can have a whole different webinar about the lack of time. Let's go to questions that has coming in on our different sites here. There's a question here asking both you, Emma, and Bo, what would you have done differently to adopt more of an ecosystem-based management approach? And what would you like to have seen? Which fields needs to work more together?
I think I mean, what we are lacking is what I touched upon before, is to tie. Also, we have tried to tie economy into this, and we try now to look at the effect of various measures and so on, but connecting the expected environmental state of the Baltic Sea to implementation of measures and actions, so we get a loop there and can discuss.
And would you say science needs to step in there? Or?
Yeah, I think we need a scientific basis for
to
that.
do this.
Yeah.
Emma?
Yeah, well, it's a little bit similar for the chemicals. Something that I think would be needed to bring this forward is to have more information about how the total effects of the chemicals that are emitted to the sea actually influences life in the sea, populations at population level. So there's more information needed about the long-term effects of this mixture of chemicals, and not the focus of toxicity of individual chemicals, and that is often not related to effects at higher levels either. So that makes it problematic to move on with these questions, to not really have defined the problem.
Okay, so it's an increased interrelation between science and the other parties, really. Another question has come up, which sort of brings us back to whether or not HELCOM is moving along, is about which are the largest disagreements in this debate on the new Baltic Sea Action Plan. Is it possible to say, or is it too early? I mean, as you said, the decision will be probably next fall. Can you already say that this is the trouble, for instance, in chemicals?
No, I can't. I don't know.
Yeah.
No, I wouldn't.
Okay,
like
so
to
we
know.
don't skip this one, yeah.
I haven't followed the kind of political discussions.
But that's going to show
line,
itself probably where the largest disagreements are. Okay. So another question linking again policy to this other policy, Baltic Sea Action Plan, is would you say that the European Commission Green Deal has an impact on the new Baltic Sea Action Plan? Is it part of the dialogue? Not enough, maybe? Or?
Yeah, it's once again one of these political questions more. But I think from a scientific perspective, we looked a little bit on various green initiatives within CAP and did some quantification. And unfortunately, it didn't give a lot
Okay.
in terms of nutrient reduction, because we think the problem lies in a little bit different areas in agriculture.
Oh, yeah, okay.
Yeah.
So it is tricky, and maybe that's something that could be brought into the dialogue agenda more. And a question to you, Emma, before we're getting close to wrapping up here. It says, once major local and regional emission sources have been identified, how is the HELCOM working on identifying ways to reduce them?
Yeah, I think HELCOM is not so active in developing measures, but
that's more up to the member states.
Yeah,
or?
but now in this process of updating the Baltic Sea Action Plan, there has been a lot of work to compile information of different measures that exist and trying to evaluate them in a systematic way. But that's extremely you often don't come to maybe knowing which sources. You often get stuck at the stage of trying to find out where these chemicals are coming from, because you need so much data, and there's often a lack of data, especially compared to nutrients.
So it sounds as if science is always sort of behind. I mean, you have this evolvement of new chemicals in the market, etc., being spread in the environment, and science is trying to keep up.
Yeah, that has been the situation. And it's also often very complex situations. For example, that you have to make a different mass balance for a local area compared to the entire Baltic Sea.
So it's, as you said, complex depending on where you are in the region.
A lot of work to do this.
So maybe one final before we wrap up. If you now could choose one thing that you would love to see happening within the process of the new Baltic Sea Action Plan, what would that be for chemicals?
I think one key thing is that, and that is also already discussed in HELCOM, so I hope this will happen, that they will work more on the mechanism to update which chemicals they prioritize and develop indicators that take a broader scope than just these single chemicals. And that is already ongoing work in HELCOM, so there are good chances that we will see it.
So they're on the route yet, right?
Well, I hope, of course, that our suggestion now for the nutrient input ceilings will be accepted and highlighted and presented in a very good way in the Baltic Sea Action Plan, so we don't have ambiguities going on afterwards, so we know what's decided.
Okay, so fingers crossed, yes. Thank you very much, Bo, and thank you very much, Emma. And thanks to all of you in the public who has listened to us and contributed with questions. Baltic Breakfast are back again on November 4th. That'll be in Swedish though, but we hope to see many of you then. But we will definitely be back again in English very soon. And on November 4th, we will talk again about biodiversity linked to restoration of areas and ecological compensation. Thanks again and hope to see you then. Bye-bye.